See, I'm creating one simple table. Okay, the employee, the ID, number, name, varchar, city, varchar. Okay. Tell me how to get unique records for ID. What type of constraint we can provide for ID? You can use primary key. Okay. So, like compulsory name should be then. I should go for what? Name should be, we should
Unique,
go for
not null. Not null, sorry.
not null. Okay. Okay. Now see what happened. First, if I want to create table, what should require? We require database and schema required. Okay, select the database and select the schema and what is shortcut? Control enter. Okay. So how's list of tables? Show tables. Okay, same thing. How to see the DDL? How can I see the DDL? DDL. Select. Get DDL. Okay, important thing. Listen carefully. So see table. Okay, and the table. So table. So this is the function. Okay, so far this is the things we can able. So far good. Okay, now come to the thing. Okay, let me insert few. I'll explain what exactly we're discussing. Insert into table values 1, Praveen. So 2, 3. Okay, so totally 3 records I am trying to insert. Okay. So fetch the data. So select the star from table. Okay, so this is my table. Now, how many records are there? 3 records are there. So this is so far good. Okay, see, this employee table contains 3 records. It contains definition. It contains constraints also available. Okay, see, in this my table contains 3 records plus constraints are available. So my requirement is that what? So in this video we'll see, in this session we'll see how to create a backup table in Snowflake. So this is important. In Snowflake, how many ways I can able to create a backup, we'll discuss in detail. This is important thing. Tell me anyone, any idea so far in SQL discussed what? What we discussed? What we discussed? We discussed what? Anyone, somebody saying? So see, this is my original table. I want to take a backup. Tell me, what is the concept we're having? C-test concept is it. So before that, tell me why we need to take a backup of the table. Why? What is the reason to take a backup? So mainly for testing purpose or data preserving. Okay, if something happened, we can go back and bring the data from backup table. So simple thing. So why we are trying to take a backup? Tell me. For testing purpose or data preserving. Tell me what is syntax for C-test? C-test.
Create table.
Okay, so create a table as. Okay, see create table. So table name as select star from old table. Okay, so old. Okay, so this is important concept. Listen. So see, so one of the Snowflake feature we're discussing today. So see, Control C and Control. So see what happened. So create a table. So what is the table name? I forgot my table name. What is the table name? So you should go for show tables. So this is my table. So C-test. Okay, so original table, I'm putting C-test. Okay. Now how to see the data by using select star from table name. Okay, so data is there, same 3 records should be populated. So 3 records. Now how to get the definition? Select get TDL. Okay, so table and the table. Okay, now see the same thing. Okay, so copy the value, open one more session, change the language to SQL and take your original table. Okay, I'll explain what exactly. So copy the same thing, open one more session, change the language to SQL and try to compare. Okay. So see, this is the original table, this is the CTAS table. And tell me what's the difference? Both are same, any difference is it?
Primary key added.
Okay, only primary key added. So this is the original table, the employee table. So columns are same, but what is not happening here?
Constraint are not.
Constants are not populating. Okay, got the point. See, constants are not populating. Okay, here you need to understand the concept is that what? Okay, see the same thing. So important. So when I go for CTES, we are getting definition. I'm getting. What about data? Data is getting. What about constants? No constants are populating. Okay, so this is important. So by using CTES, now we are getting definition, data, and the constraint. So this is one thing. Okay, we'll use this one also in the real time. So CTES to take a backup of the table for testing purpose or data preserving purpose. So definition plus data plus no constraints are getting populated. So this is so far good. Okay. Now same thing. Now what happened? This is fine. Okay. So next thing is that what's next thing? Okay, so one more concept is there, that is like, so far discuss CTES. Now like create, so remember syntax you should remember for all these use cases. Create a table name like old table. Okay, so this is syntax. So create table name like old table. Okay, so create table, so table name employee T like is the key. We can give any name, and what is the old table? So this is the old table. So control enter. So see, table has been successfully created. Where exactly it created? In this ADF training DB training schema. So copy the table name and see the same thing. Now tell me, data populated? No, no data is populated. Okay, see the definition. Copy the same thing. Go to here. 1 second, give me. Yes. Now see, go to the same thing. Okay, so see, this is the table. So control V and try to compare one more time. Tell me any difference is there?
No.
No. So see, only name is different. So what's the conclusion? If I go for like, we are getting definition. Okay, so data, no
No
data,
data.
and the constants are populating. Sometimes what happen? No? So we want to create a table without a data. Then what I can go for? Tell me. So I want to create a table, okay, without data. Tell me how many ways we can create?
Like by
Like.
using
Only like one more concept is there in SQL. Tell me, Clona. Understand the question. Without a data should not be populated.
Where 1 is equal to 0.
CTES with the false condition. Got it? So CTES with false condition. See, I want to create a table without data. It can be like or without or CTES with, but what's it? But what is CTES drawback? No. Tell me no. No constraints are populated. No constraints. Okay, that's what. So depends on the use case. Will work is use both things. Okay, CTES will work like will work. Okay, so far good. So one more important thing is that what? Let me go to Snowflake. Okay, see one more feature that is cloning. Okay, so cloning. Okay, see create table. So table name clone old table. Okay, so this is the syntax. Okay, see create table. So table name. So see your table name. Okay, clone. We can give any name. So clone is the keyword, is the functionality. So create a table name, clone old table. Okay, see the same thing. Now how to see the data? Control C. Okay. So put here put here. Okay, now see what happened. Tell me data populating. So 3 records are populating. What about definition? See the definition. Copy the definition. Control C. Go to Snowflake. Go to Notepad++. So Control C, Control V, and try to compare. Okay. Tell me any difference is there?
No.
No. So what we can conclude? So for both these things, tell me. Okay, see Control D. So I'm trying to create clone. Okay, see clone. Definition getting, data getting, constants are getting populated. Okay, so this is the conclusion. See, so what you're discussing in SQL. So in SQL, we know CTAS only. In Snowflake, if you want to create a table without data, we can go for what concept? Go for like CTAS and clone. So by using in Snowflake, if we want to create a table, so we can go for CTAS, like, and clone. So far good. So this is up to here, no worries. But what happened? No. So tell me, Snowflake is free, yeah?
No.
In
No.
Snowflake, see right now we are using what edition? We are using free trial edition. Okay, see trial edition. See what happened? It's having what? So 252 credits. So how many gets giving by default Snowflake for practice purpose? How many gets given? 400 gets. 400 gets. But what happened? See what I did? I have consumed. See, so trials credits used. Now nothing but what? See what it means. What it means. So if you do anything in Snowflake, Snowflake will be charging. Okay. So what charges it will try to do? It will try to do mostly 2 types of cost charges: storage cost, and one more thing is that compute cost. Important, listen carefully. So see, so whenever I'm not trying to see the videos before coming the session, it'll be comfortable. See, so ultimately at the month end, so every month, so okay, assume like our client needs to pay to whom? Snowflake. So for what? For using their services. What is SaaS? Tell me.
Service.
Software as a service. Okay, see, whatever the service we are using, we should pay to them at the month end. So what type of cost we should pay to Snowflake, the client? The storage cost and the compute cost. What is storage cost meaning?
Storing the data.
Storing what data? Our table data.
Our table
okay.
data.
Okay, see here you need to understand the concept is that what? Storing our table data. Okay, see where exactly we are trying to store in the Snowflake. Okay, see simple thing here you need to understand now here. So ultimately Snowflake, we need to pay to Snowflake based on the storaging and the compute services. Okay, so before that, now let me help you. Important, listen carefully. If you're able to understand now, Snowflake is simple and easy things. Okay, so this architecture is important. Okay. So this is important. Listen carefully. See, there are 3 layers are there. Okay, Snowflake architecture is very, very important for improved perspective and real-time understanding perspective. See, cloud service, compute service, cloud storage. Tell me. So we'll see the same thing in detail. What are 3 layers are there in Snowflake architecture? Tell me.
Cloud service.
Okay, see, cloud service.
Compute service.
Compute service. One more thing.
Storage.
Cloud storage. Okay, see, cloud storage. Okay, see, this is important. See, cloud service, computation, and storage cost. Okay, see, here also get charges there. Just now I'll discuss this thing. Cloud storage, compute services. Now, question is that what? Let me copy the same thing. We'll see detail. Hold on. Okay, now let me go back here. Okay, so let me see the same thing. So see, I'll explain these things. Let me go to here. Okay, I am trying to create a table. Okay, see table. So create a table. So T6 ID number. So tell me this is a what? DDL definition. Okay. Now control enter. Now tell me table is created. Okay. So here you need to understand what. So see which layer will come into picture. Any idea out of these three layers? Okay, tell me where exactly this layer will pointing to, which TDL pointing to. Anyone, any guess?
Cloud service.
Compute service and cloud storage.
No, not. See, only table. No, it's a DDL. So I am trying
Cloud,
to create a table. What happened? So it will be there in the first layer only will be coming
cloud
into
service.
picture. Okay, see the first layer. What is the first layer? That is cloud service layer. So see, so first now whenever we create a table, see whenever we create a table, so which layer will come into picture?
Cloud
First layer,
service.
Cloud
service.
service. Okay. In this cloud service, what happens? Some services are there. That is nothing but what? Okay, see,
Metadata.
access control. Nothing but what? See, whether you are a valid or proper user or not. Okay, and it will check the permissions or access you have. Okay, simple thing. So suppose if you go to a company, what happened? You should have ID and access. Same thing. If I want to perform anything, I should have access and permission on the particular database object. Now what happened? Tell me now, how many columns are there in this table? What's the table name? T6. Column name is ID. Data type is number. How many records are there as of now? 0 record. All this metadata information. Metadata nothing but so data about data. So who is holding this information? Tell me. Data about data. Which guy?
Cloud
The
service.
in the cloud
Cloud
service
service.
metadata. So see what happened. No, I have created table. When we created creation time, so column, number of columns, data types, number of records. All this information is holding by whom? By the metadata layer. Okay, so whenever create any table, which layer come in picture? Cloud service layer. The metadata management will come into picture. This is the first thing. Okay, so this is the thing. Okay. Now see what happened now. Let me insert one record. Listen carefully. Insert into T6 values 1. Now see the same thing. Now tell me, see if you see now, this is what status? I'll explain at a point of time. Tell me what status?
Suspended.
Suspended.
Suspended. Okay, now I am trying to insert a record. Okay, see where exactly we're trying to insert the T6 layer. Now see what happened. Its status changed to what? Into
Started.
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 So we are doing anything manually? Yeah? No, it is getting automatically. Now question is that what is one record? Where exactly storing? Anyone? Any guess?
Virtual warehouse.
Storage layer.
No. Physically we're storing in the storage layer. No,
Storage.
Storage layer.
storage
Yeah.
layer. Okay, so see here you need to understand. So see, let's say 0 record. Now what happened? Now 1 record. Now see what happened? It's need to be metadata need to be updated. Now question is that what? No, see how the data we can directly insert into the cloud storage layer. Which layer come into picture to process this data? Which layer come into picture?
After compute service.
Compute
Compute
services.
service. So if you simple thing, if you want to do any operation, what we require energy. Same thing. If I want to perform anything now, what I require? I require some power, computation power. Computation power gained by whom? By the
Compute service.
compute service that is contains virtual warehouse. See what happened. So see now our data will be physically storing in which layer? Storing in cloud storage layer. Okay, in the form of micro partitions. Okay, see our entire data will be stored in automatically micro partitions data. Okay, micro partition nothing but it's a unit of storage. Our data will be divided into small chunks, and it will be stored in where? In the storage layer in the form of micro partitions. See, so where exactly our data is storing in the storage layer in the form of micro partitions. So this information is who is holding by the metadata manager. If management, if anything, no, it will get automatically reflected or updated. Now question is that what if you want to process, nothing but what I want to perform DML TRL. So inserting the data, updating the data, fetching. We require what? We require computation power. Computation power given by whom? By the
Compute
compute
service.
services. Compute services. Compute services contains what? Contains
Virtual.
cluster of
Virtual
machine.
warehouse.
Cluster of machine, nothing but say virtual
Warehouse.
virtual warehouses. Okay, simple thing. If you take a phone now, what happens? Phone contains storage plus RAM. What is the purpose of storage? To store our
Files.
files, images, the same thing. What's the RAM purpose? For processing purpose. Okay, same thing. Got the point. So here you need to understand what. So our data will be stored physically in which layer? In the storage layer in the form of micro partition. This information is holding by whom? By the metadata. Here you need to understand what. If I want to process, if I want to perform DML, DL, we require what? We require computation power. Computation power nothing but it's a cluster of virtual warehouse. Got the point one more time. If not able to understand, let me put, you can able ask the question 1 second. Now see, now I am trying to suspend this warehouse. Okay, suspend. Now see what happens. See, create table. So T7 ID number. Okay, see the same thing. So number. Now control enter. Now see what happened. See, table has been created. Now see here what happened. Tell me. It's in which status? Still it is in suspend status. What is the conclusion we can say? So DDLs, no need of compute, no need of warehouse, no need of virtual warehouses. Here you need to understand. So details are happening at which layer? Which layer?
Cloud services.
So cloud services. What we can conclude? Cloud service operations, no need of virtual compute service. Got the point? One more time. So here you need to see the operations which we perform the cloud service, no need of what?
Compute services.
No need of compute services. Clear? This is important point. So here you need to understand what I am trying to create a table. It's a DDL. So DDL is nothing but it's a what? It's a metadata operation. So metadata operation doesn't require any computation power. Clear? This point is important. So metadata operation doesn't require, we can conclude, metadata operation doesn't require any, any computation. Okay, so same. So far good. Now what happens? See, now I am trying to insert a record. So insert into, tell me, insert into T7 values. Now this is what operation? It's a DML. Tell me, DML require computation power or not?
Yes.
But what happened? It is in what status? It is in suspend status. But what happened? See, when I try to insert, what happened? So when you perform, tell me, when you perform DML, which layers will come into picture?
Compute and cloud storage.
Only two.
Cloud services part.
Okay, it's a metadata. Okay, so three layers will be coming picture. When you perform DML or DRL, all the three layers will come in. But what happens? See, now it changed to status to started. Why? Because there is a parameter that is, we'll see at the end, auto resume is enabled. Got the point? So this is the way we can able to make it working. So far good. Okay, see, this is the functionality. Got the point? When you so DML require, so DML require computation power. See all the layers: cloud, service, compute, and storage. All the three layers will be coming into picture. Okay, so this is so far good. Now see what happened. Now see, this is fine. Now see, it's in on status. Now question is that what I create one more table. Tell me, does it require computation power or not?
No.
But how can you confirm?
Status.
Already started. Now how can you confirm? See, if you see now, so query details, click on three dots, view query profile. Okay, see query details. Tell me, warehouse size is what?
Null.
blank, nothing but
Blank.
what? So it doesn't require any computation power. So by see what happens simply. Okay. So I am trying to execute a statement. So select one. Now see what happened. Snowflake will give one query ID for every statement we execute it. So we execute it. So this is important. So whenever we execute any statement, no, Snowflake will be giving unique query ID and give unique query ID. Okay, see control enter. Now see the three dots, copy the three dots. Okay, copy query ID and put here. So this is the same thing. Same query I'm trying to execute one more time. Okay, see, click on query details. So see three dots, copy query ID and put here. Tell me both are same. It's a
Different.
unique, different. So unique thing it will be generating. Now question is that what? See when you click on three dots, view query profile. See in the query details, what we can see where see status, duration, start time. So see query ID, end time. So see now warehouse size is what? It's a
Blank.
blank, nothing but it doesn't require any computation cost. Okay, same thing. So let me insert one record. Okay, see one record. Now see the same thing. So view query profile. Tell me it require or not? Any guess?
Yes, it will.
Okay, see. Now where exactly our data is storing? See, it is storing in the see where exactly it's storing in which layer? In the where exactly our data is storing?
Cloud storage.
Storage in the form of
Uh,
micro partitions, no?
Micro part.
Okay. So micro partitions. Okay. So got a point. So far good. Okay. If we go to here now, what happened? So see, it is having extra small. It's a size. See what happened if you see the sizes. Okay. See extra small, medium. So these are the sizes as the 6XL. Now question is that what is it's using which warehouse? Snowflake learning warehouse. What is Praveen SF?
User.
Username. So user. Okay. Warehouse user. Now question is that what does DML require computation power or not?
Yes.
Yes. Okay. It requires. Okay. This is the way you can
Yeah,
able to conclude. Got the point? So this is the functionality. Got it?
Mm.
Clear so far?
Yeah.
Okay. So this is the functionality. Clear? This is the way you can able to make it working. So you see now here you need to understand now. So what is the conclusion? So when you try to perform any operation, we require computation power. And here what happens? See this metadata operation doesn't require any computation task. Okay, so far this is the theory part. Now what happened? See, this is so far good. Now question is that what? So let me go back here. Listen carefully. Little bit confusing, but we need to connect all the dots. Okay, see, let me take the same thing. Now see what happened. Now employee table contains what? Three records. So three records nothing but what? So three records nothing but tell me we are inserting nothing but we have what type of cost?
Compute cost.
Compute cost. Only compute cost.
Cloud storage.
Cloud
Storage.
storage.
Storage is available. No, storage cost is available. See this because now I have inserted three records, nothing but so computation power required and storage cost required. Okay, this is so far. Now question is that no CTAS is there. The CTAS will have compute cost or not? Any guess?
Yes,
Yes, sir. How can you confirm?
because we are inserting three records.
Three records. Okay, see, let me go back. See, so this, see, we can able to get, see, last 25 queries or see, or go to here. Okay, see. So see, there is a, so scroll down, so navigate. So see, every time they keep on changing the UI. See, where I should go to monitoring. So see, monitoring, there will be query history will be there. See, in the monitoring query history. So queries, what are the execute the query now? Our queries will be available. Now what we should go for? There's so many queries are there. What I should do? Go for filters. What is the thing? SQL
Query type.
text. SQL text. Okay. So query type we not discuss. Now what's the table name? Table name is what? Employee TTA. CTAS table. CTAS. Okay, see, now we are discussing what now? Out of three concept, nothing but CTAS like clone. So which one is usable or which one is okay flexible for us? Okay, so that we can able to reduce the storage cost and computation cost. We are trying to compare these three things. Okay, so SQL text. So go to monitoring, query history, go to filters, SQL text, control V, and apply filters. So this is the three things: get DDL, select the data. Now question is that what? So to CTAS. So same syntax. This is the same. Click on this one. Tell me warehouse required or not? Computation power required or not?
Yes.
Yes.
Okay. See now nothing but. So when you're using compute, nothing but we require compute cost is associated or not? Tell me. Compute cost is there, compute cost. So we are trying to conclude compute cost is associated for CTAS because physically data is there. So far good. Okay. Now let me go here, go for one more. There is filters, SQL text, control V, go for like apply filters. Now see what happened, go to like, tell me, so before that tell me anybody, does compute cost require or not for this one, any guess?
No,
Why?
because there is no data.
No data, correct. See, so create table, it's a metadata operation. So the metadata operation, nothing but no compute cost is associated. So far good. Okay, same thing. One more important thing, clone. Any guess? Anyone, any idea? Clone, storage will be there or
Yes.
not? Compute
Yes.
cost
Storage
is
is
there?
there. Storage is there.
Tell me. See, compute. Okay, now see what happened.
Huh?
Anyone? So I'll explain. This is important. Okay, so see, no compute cost is associated. So this is important. I'll explain. So see, so CTAS compute cost is there. Like clone, no compute cost. Okay, I'll explain the same thing. So up to here, clear so far? So these two are clear?
Yes, sir.
Compute cost is associated because data is there. So see, but here data is there. Tell me, cloning has data or not? Data is there. But what happened? So if you see the Snowflake, go to Snowflake projects. So you can view name so that it will be comfortable. Okay, see, view the name. Okay, we are discussing clone concept. Okay, clone. So select a star from what is the table name? So I forgot my table. How to get the table name back?
Show tables.
Show tables. Like we can go. Okay, see, data is there. Generally, what happened when data is there? What we should get? We should get compute cost and storage cost. Okay. Now see here what happened. See, no compute cost is associated. I will explain the same thing. Listen carefully. Important. So assume this is the table. Listen carefully, important. So entire Snowflake can be understood by these things, okay? So this is EMP table. So contain 100 records. 100 record nothing but 100 MB storage is there, okay? Okay. So now what happened? See, this is the table. Okay, now, so I am trying to take a normal table backup, CTAS concept, okay? So Control C and Control V, okay? So now tell me now what happened? Tell me. So normal CTAS. Now how much storage cost will be there? Storage cost 100 plus 100 plus 300 MB.
And
So storage is 300 storage cost and the compute cost also is associated. This is normal table. Go to the paint, submit yourself. Okay, see, go to the paint. So this is my normal table. Now what happened? So this normal table, I am trying to take a backup. So see, so backup. Okay, see backup. Okay. Now point in understand is that what all these three tables are point to the same storage. Okay, see the same. So this is important. If I go for clone, now what happen? All these three tables, employee 1, employee 2, employee 3, all these three tables are pointed to the same storage. But what exactly here copying? We are copying only the
Table structure, metadata.
metadata of micro partitions. This is important. Okay, see? So control V. So here you need to understand what? So we are trying to take a backup by using clone concept. Nothing but what? See, this is normal C test. So normal C test, nothing but exactly we are trying to replicate the same storage, same compute task is associated. Question is that what? Now I am going for cloning. So cloning nothing but see, this is the cloning, this is the cloning. Now all these three tables are pointed to the same storage. See, all these three tables are pointed to the same storage. Now what exactly we are trying to copy? Copying only the metadata micro partitions. One more time. So if you see this, okay, see now what happened? Tell me normal, what we discussed, tell me. So where exactly our data is storing?
Cloud storage.
Tell me in the
Cloud storage.
storage layer. Okay, see this layer. So now where exactly our data is storing? So in the form of micro partitions. Now question is that now this micro partition information, who is storing like number of records, distinct records, maximum value, minimum, who is holding by whom?
Metadata.
By the metadata. Okay. Now, if you see now, when I go for normal C test, now again separate storage, separate micro partition storage. But you see here what happened in the clone, what exactly it's copying, any guess? Copying only the metadata of micro partitions. I'll explain one more time. If you see this image, you'll get complete clarity. So see, this is important. Now see here what happened. So P1, so this is what layer? Metadata is layer in which layer? It's a what layer? Metadata is available?
Cloud services.
In the cloud services. Okay, now tell me what is P1, P2, P3? It's a metadata of micro partitions. Where exactly our data storing? In the storage layer in the form of
Micro partition.
micro partition. This micro partition information, the metadata is holding by whom? By the metadata layer. This is clear so far? So see, here you need to understand. So suppose there are so many micro partitions are there. So only employee table contains 3 micro partitions. This information is holding by whom? By the metadata layer. Now see, I'm going for C test, nothing but what? So table we are trying to replicate, nothing but storage cost associated as well as we are performing what? We are performing some inserting, like creating and inserting. Now what we'll get? We'll get storage cost as well as what cost associated? Compute cost.
Yes.
This is a simple thing. So P1, 3 micro partitions, data is physically. Now I'm going for C test, nothing but what? So physically our data is storing again, nothing but storage cost is associated. Now question is that what if I want to do the storage, nothing but inserting, creating, we require what? We require compute cost is associated. So what's the conclusion? Tell me, C test require compute cost or not?
Yes.
Okay, see,
Compute plus
compute
storage.
cost, storage cost is associated. So this is the functionality. So what about like storage cost will there? No storage cost. Why?
No data.
No data. So up to here clear. So see, this is normal thing. So no, it's normal behavior. Compute cost associated because we are performing some operation. Storage cost because physically data is existed. So but when you go for cloning, no compute cost plus no
No storage.
storage cost. How can you conclude? Now, if we see no compute cost, we discussed yes or no? How can you prove no compute cost? Because in the query profile, there is no warehouse is associated. Got the pointer. The same thing now, what happened now? We want to prove no storage cost. If you see this image, no? So see, listen carefully. You need to understand. So theory part, you should understand the practically. Okay. So take the screenshot. Now tell me what happened. So this is my main table. This is my clone table. So these two tables are pointing to what? Pointing to the single storage. Now, what exactly we are trying to copy? Only the metadata of
Metadata.
micro partitions. So what exactly we are trying to copy here in the normal table? The actual data, actual partitions, and the metadata. But here, what exactly it's copying? Copying the metadata of micro partitions. Now, question is that what? So now it's a what operation? What operation we are trying to perform? Metadata operation. Tell me, metadata operation require compute cost?
No.
No.
No. Now these two are pointing to the same storage. Now see, tell me now what happened. There will be no storage cost associated. So here you need to understand it's a metadata operation. That's why it doesn't have the physical storage. No storage cost and no compute cost is associated. That's what the functional. Getting it so far?
Yes.
Getting it?
Yeah.
No storage cost. No storage cost and no compute cost. What is the difference?
Now, compute cost, tell me what is compute cost? Tell me,
Yeah.
ultimately, we need to pay to what type of cost to Snowflake? Storage. Storage cost. Storage cost, nothing but what? Our table data. We are storing in which layer? We are storing in storage layer.
Clouds.
Layer.
Storage layer. Storage, nothing but tell me, for to storing the, see, there are two separate, see, storage and compute are independent. Okay, so there are independent. Okay, so if you use for storage, we should pay for storage. If you use for compute, I should pay for compute cost. Now, question is that what? Now I'm having 100 records are there. Now, what type of storage? Tell me what type of cost you should pay? Storage cost. Now, if you want to insert this 100 records, what I should do? I should require computation cost. No, simple thing. When I perform this layer in the storage layer, I should pay for storage cost. When you're trying to insert, when you're trying to fetch, we require computation power. Computation power, nothing but we should pay for compute cost. Got it?
Yeah.
Okay, see, no storage and no compute cost, nothing but what? So ultimately, cloning is called as zero copy cloning, or it's also called as tell me why it's called as zero copy cloning, because no storage cost and no compute cost. Why? Because it's a metadata operation. It's a metadata operation. We are not copying the data physically. We are copying only the metadata of
Metadata of micro.
micropartitions. Okay, if you see these two images at a time, see what happens. See, so see, we can see clearly that separate storage cost. If you want to do the storage, we require compute. So storage cost and compute cost. But here what happened? Only single storage. Only this guy need to pay the storage cost. There is no storage cost. And say metadata operation, no storage cost is associated here. Got the point? So this is the way we can able to get it done. Got the point?
Yeah.
Here P1, P2, P3 are table instances.
What P1? It's a micro partitions, the
Micro.
definition. So it's simple thing. Suppose, so in the address book, tell me, suppose I'm staying in Hyderabad. Tell me, so in the book we are this is a virtual, but where exactly our data is, where exactly you're storing? I'm staying in Hyderabad. Same thing here also. Where exactly our data is storing in the storage layer. This information is holding by whom? By the metadata. This is the metadata. So data about data. Suppose there are 100 records are there. Out of 100 records, where exactly these records are storing, we can find in the metadata by Snowflake. Okay, this is the physical data, this is the metadata. Okay, same thing. Okay. Now see the questions, then you can able to ask. Tell me, suppose I'm having 1 GB data. Okay, now which type of tape which I want to take a backup? Which one is preferable and why?
Zero cloning.
Cloning, because no storage cost
No
and no
storage.
compute cost. Tell me this operation is fast or it will be slower operation?
Fast.
Fast,
Faster.
because only metadata copy. No, it's also called as fast cloning or zero copy cloning. Okay, so this was the functionality. Okay, let me go to the task. Okay, see this task. Now see what is cloning? It is used to take a backup or replication or okay, see backup of a table. How to clone a table? Tell me syntaxes. Remember, for everything I should prepare the syntax. Okay, definition and use case. Okay, so tell me syntax. So create a table. So table name, clone,
Clone.
Old
Whole
table.
table.
Old
Okay, if
table.
I want to take the schemas, enter schema, we can take a backup. Okay, so create schema name, old schema. Same thing. If I want to take enter database backups, so create a database. So DB name, old DB. So enter database, we want to take a backup. Suppose see, if I take a enter database backup, what happened? Tell me.
Entire tables views will come.
Entire databases, everything will be coming. Okay, see, this is the all the schemas will be populating. Okay, so far. So same thing, Control X. So practice required. Theory I'm saying clearly, but you need to require practice. Okay, this is so far. Now same thing. Now let me come to the thing. Okay. Why cloning is called as zero copy cloning? No storage cache and no
No
compute
computers.
cache associated. Okay. So in which situation you have used cloning in your project? Tell me.
For
For backup purpose or for
Backup.
testing purpose or
Testing
data
purpose.
preservation purpose, we can say anything. Okay. Does cloned object will have storage?
No.
No,
Prove me.
because warehouse size it does not.
Yeah.
Warehouse
Warehouse.
size is for what? Compute, no?
It is for computation.
No,
Computation.
see, this is different. So remember, so you need to understand both are different. See, this is, okay, see, 1 second. So storage is different and compute is different. Now you're saying like, so warehouse is not there. Warehouse is not there, nothing but what type of cache is set for warehouse?
Compute.
Compute cache. Now my question is that what now? So does cloning object will have storage?
No, it will show
No.
only the
No.
addresses of the partition.
So my question is that what theory is fine, but practically how can you prove?
Because it has common storage other
No,
than
that's
main
fine.
table.
No, that's fine. So theory is fine, but I want to show practically. No, you're showing
Query
something.
result.
Warehouse
Query
size
result.
is
Can
blank.
see the
No. Again, warehouse size. Don't get confused. Warehouse size is for what?
Compute.
For computation.
Compute. Yeah.
Then again, why storage will come into picture? That is compute. So see, don't get confused. So warehouse is for only computation task. Storage is this is independent thing. This is independent thing. If you
Okay.
perform, will get cache. If you perform, this will cache. Now question is that what? Compute cache is fine, but question is that what? So does cloned object will have storage? I want to check the storage cache is associated or not. How to check? See, there is a information schema. See, select. If you see for every database, no, see, this is other dev schema. These are we have created, but see what happened. This is what schema? This is a metadata. So this is given by whom? By the Snowflake itself. Information schema. So information schema dot. So tables will get what information? Your entire table information. If you get columns, we'll get all the columns information. Same thing. Now what I want to get? Table, storage, metrics. So limit 10. What is limit 10? Nothing but what?
10
10 records it will try to give. Okay, say. Okay. Tell me now, I'm fetching the data. Does it require computation cost or not?
Yeah. Yes. Oh, this is metadata, I think.
No, if we want to fetch, no, we require, because now we're
Yes.
doing filtering, we require computation cost. Okay.
Yes.
So far good. Now question is that, see, now what happens? See, now, so there are so many databases are there, but I want to get my database. How to get this database by using query?
Database.
Where table
The catalog.
catalog nothing but a database. How to get this database in this session? You should go for current
Current.
So current session.
database. So don't get, these are basic things. Okay, and how to get a schema? Table schema equal to current schema, control enter. Okay, see the same thing. Okay, now there's so many tables are there, but I want to get my tables. What are the tables? Employee. Tell me, I want to get my tables. Employee. These 3 tables. How to get 4 tables? Under table name.
Like employee.
Like. Okay, so like. So employee.
Star percentage.
Underscore. So don't get confused. Remember, SQLs are important. Percentage. Now you'll get 4 tables should be populating. So employee T, employee status, employee clone. Okay, see, table catalog, database name, schema name, table name, ID, clone group ID, active bytes. Okay, see the same thing, important. So important, listen carefully. Now see here what happened, employee T status. Now seeing that, tell me all this four, see, by seeing these tables, tell me which tables are main tables, see the data and tell me. Any guess which
Employee,
table?
employee
Employee
is
T underscore T. Employee underscore T.
How you're saying?
So we
because
have
of the group ID.
we added underscore like underscore CETAS.
Suppose see employee 1, employee 2, employee 3, employee 4. Now which is the main table?
Employee T.
Employee underscore T.
No. I'm giving the names now. Employee 1 table, employee 2 table, employee 3. Name is employee 1, employee 2, employee 3, employee 4. Okay, so I'm not giving the T. So table names is employee 1, employee 2. Now which is the main table?
Clone group ID, we can compare
Employee
ID with the clone group ID.
Hmm?
We should compare ID with the clone group ID.
Correct. See now, see what happens. So see your data and you should see the data completely. You are seeing one thing and you are concluding. Okay. Now see what happened. So see, you need to conclude these two columns. Okay. So same.
Same.
Yes.
Same. Okay. What about this thing? Same. Same. So what about last one?
Different.
No.
No. So when ID equal to clone group ID, nothing but both are base table or main table. So this is important. When ID, very, very important question. ID equal to clone group ID. So nothing but what? It's a base table or main table. Okay, so same thing. Now what about last one? Same?
No.
No, it's a clone table. Now tell me this clone table is pointing to whom?
Main table.
Main table.
Yeah.
Got the point?
Yes.
So see, when ID and clone group ID not equal to nothing but say cloned table. Okay, got a cloned table. Okay, so far good. Now come to one more image, then you'll get clarity. Simple thing, concepts. Okay, just it's a concept only we are trying to implement. Okay, see the same table. Let me take the screenshot. Tell me, so 4 tables are there. Which are main tables?
That is main table, not main table.
CETAS.
Main table. This is okay. What about second one? See, this is getting cloned from the same thing. Okay. Now here, see now what happened. Tell me. So in the employee table contains 10 records are there. 10 records, nothing but what? It's occupying 3584 bytes. Nothing but what says storage cost is associated. So now tell me, like will be storage cost will be there? No, zero.
No.
Okay. What about CETAS?
Yes,
Yes.
we have storage cost.
So cloning?
Zero.
Zero.
So how can you conclude? If anybody asks now, what you should check? What you say in the information schema table storage
ID and-
matrix? Not ID. Active
Active.
bytes
Clone
will
group.
be
Zero.
Oh,
byte
active.
will be 0. Okay, so it will be 0. So how to find out? By this question is that what? So does cloning occupy storage or not? Answer is no. Okay, how
No.
can you prove? So in the storage matrix, table active bytes will be 0, 0. But see, your question is that, no, what happened? Let me take the same thing. Now see what happened. Tell me in the employee table, 3 records are there or not? As of now, 3 records are there. Okay. But what happened? There is 0. See, there is a latency concept. Is there? What is latency meaning? What is latency definition? It's a delay. Okay, so latency nothing but some time delay is there. Okay, see. So see here, you need to understand what. So there is a 1 hour to 2 hours delay is there to get data should be updated. There is a delay of 1 hour, 2 hours is there. Okay. Tell me after 2 hours, where exactly suppose it having 10 bytes of storage is there. Where exactly 10 bytes will be populated? Tell me.
Active bytes.
No,
Active.
where? That's fine.
In
Where
the
exactly?
active bytes.
Tell me in the employee table it have 0. What will be there? It will be 10 will be there. What about like?
0.
0. What about CETAS?
Yes, 10.
10 will be there. Why? Because storage. What about clone?
0.
0. After 2 hours, if you see the data now, it will be 0. It will be 0. So what's the conclusion? 0 copy cloning doesn't have any
Storage
storage
cost.
associated. Okay, how can you prove in the information schema dot table storage matrix?
Right.
Clear?
Yes.
Yes.
So question is that now come to the question. So see, question is that what? So does cloned object will have storage?
No.
No. How can you
No.
prove? In the table storage matrix, active bytes will be
Active bytes.
0 after 2 hours latency. So when you make any change to cloned object, does it get to base table or not? Suppose let me come to the conclusion. So create a table. So CT69 ID number. Tell me it's a what operation? It's a metadata operation. Okay. Now insert into T69 values. Now what operation? Now which layers will come into picture? All the 3 layers
All
will come into picture. Storage cost and compute cost is associated. Now fetch the data. Select the star from T69, control enter. Now see what happened. So 3 records are available. So far good. Now how to take a backup? So create a table T69. Okay, see clone backup. Tell me, does it require computation power?
Not
No.
required.
No. How can
No.
you confirm the query profile? Now tell me, does it require storage cost?
No.
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 No. Where you can check in the table storage
Backup.
matrix,
Yeah.
active bytes we can check. Okay, so far good. Now see, now both are having how many records? T69. So both are having, okay, how many
3
records?
3 records.
So three records. Three records are there. Okay. So three records are there. Now question is that what is asking? So when you make any change a cloned object, nothing but what? Let me insert one more record. Okay. Let me insert a record. So 11, 22, 33. Where in the cloned
Clone.
table? Okay. So see control enter. Now see the clone table. Now how many records are there in the clone table? It contains 6 records are available. Okay. Now question is, see 6 records are there. Okay. Now question is that now what's saying? When you make any change a cloned object, does it get reflect the base table and vice versa? Question is that what will mean now? These 3 records will be popped in the clone main table or not?
No.
No, no,
Why?
no.
Why? See.
Because both are independent.
So
each
see,
other.
no. What's the conclusion? See, so up to here, what happened? Both are having the same storage, same records. But when you try to insert a new record, what happened? This will not be reflected because both are independent to each other. So answer is, so both are independent to each other, we should say. Got the point, huh?
Even we insert the base table also, it will not reflect.
It will not reflect. We'll try to conclude. Okay. Vice versa. See,
So
let me
now
one second.
cloud.
One second. Hold on. Now see what happened. Now I am trying to insert 100. So 200 and 300. Okay, control enter. Now where exactly we're trying to insert? In the main table. Now what would you see the same thing?
Table.
When you try to see the, now where exactly? In the cloned table. Now see, only we're getting, so see, when we are getting what? Tell me, we are getting and not getting. So what's the conclusion? Both are independent to each other. So when you try to perform, so see now what happened? Okay, only it will be reflecting the particular table on. So both are independent. 1 second, let me conclude. You can get it. See, beauty like the storage of what? So information schema dot table storage matrix. What are the columns we should check? Tell me columns.
Clone group ID and active bytes.
Okay, see. So clone group ID and active bytes. 3 columns are important. Okay, so far active bytes will be 0. Okay. So a new record is the cloned table. Does it have storage or not? Anybody? So as of now, see what happened.
No.
Important. No, hold on.
What?
Now let me take this. So T69 table. Okay, listen carefully. You need to, okay, see the practically, so theory part, you guys are good, but practically you're not getting the things done. Okay. Now, how many records are there? You need to visualize, then only you'll get. How many records are there? 6 records. 6 records are there. Now, I tell you to take a backup. How to take using clone concept. So, why are preferring no storage and no compute cost is associated. Okay. Clone. Now, see what happened. Now, see, now both are having the same storage and no compute cost is as for the clone. See, as of now, what happened? So, 6 records are there. Now, question what is asking? Tell me. A new record inside the cloned table. So now let me insert a record, single record I'm trying to insert. Okay. Okay, so only one record. Okay, assume like I'm trying to insert. Okay, one record. Okay, now question of how many record? Tell me now this data will be reflected to the clone table, main table? No,
No.
because
No.
both are independent. Now what's
Independent.
asked? Now see question. See how many records are there now? 7 records are there. Now
7
what's the question?
Where
A
is the
new
sto-
record is does it have storage or not? Tell me
Yes.
the new
Yes.
record will
Storage cost. Yes.
for what? Only one record or entire 7 records?
One.
One
Only one
record,
For
record.
one
one
record.
Only one. If storage is there, then where it will be stored the data? In which layer?
The
Storage.
storage services,
Ah,
cloud storage.
don't confuse. So storage service or storage service different?
Uh,
So tell me. Storage or compute?
Storage.
Storage, no, storage layer, no
Storage.
storage.
Storage
So
layer.
question is that what
Yeah.
we want to pay to the all these records or only which record?
One.
One record.
One
Last
record.
one record. Where exactly is in the store in the form of
Micro
Micro partitions.
partition. So see now we need to pay for only what? Only
That
for this extra one partition.
One
only.
record.
Okay, so got the point. See now suppose there are 1 million records are there. Suppose see I'm having 1 million records are there. Okay, if I go for clone, no storage, no storage. Now what happened? Now I have inserted 10 records. Now what I should pay only for 10 records,
10
only for the
records.
modified micro partition only. So new record we should new micro partition. So we should pay for only MP4. That was the point. Okay, got the point. So this is the function.
So we have to pay no storage cost plus compute cost, right?
No storage cost. What no storage cost?
No, the particular partition we need to pay the storage cost.
Yeah,
Okay.
for particular partition, we have to pay both.
So remember conveying also important. So you're saying no, you're saying like no storage. So we should pay for what? So existing 3 records plus
Yeah,
one
for
record.
that we don't.
One record. Okay, so that's what. Okay, see. So this table B doesn't have storage cost, only for storage cost for the micro partition 4.
Yeah.
Then we need
Same.
to check the storage cost in the active bytes only, right? This particular partition.
Only this active bytes one, active bytes. Everything is active bytes one. Okay. So can you perform DMLs on the clone tables, sir?
No.
No, why man?
No.
We
So we
Yes.
inserted one
Perform.
record, right? That is
No.
DML.
No, understand the question. Can you perform DML operation on clone tables? Tell me. So insert is a what operation?
yeah.
DML, no? We
DML.
perform, no?
Yeah, DML, correct. Yes, sorry.
Yes, no? So don't get confused. See, answer is yes. How will it impact original tables?
Nothing. Both are independent.
No impact. No
No.
impact. No impact. So
No
see,
impact.
so you should visualize. So theory part you're getting while implementing, no, you're getting confused. See, just now we perform DML. You see, we can perform anything on the main table or clone table. So both are independent. So it doesn't have any impact. So there won't be any impact. That's what the function. Okay, got the point. Huh? So this is the way we can able to make it working. Clear so far?
Yes.
Yes, no, this is
So
the
we are inserting one record means DML operation, right? In that case, they need to charge computation also, right?
compute cost also associated, no?
Along with storage.
Okay, see, let me
Compute plus
execute
storage.
storage. Let me
Plus
confirm.
storage.
Okay, go for three dots, view query profile. Will be warehouse will be associated. So warehouse nothing but we should pay. That's what the point. So DML we discussed already. It required computation power. Now, if you want to get storage cost, go to storage metrics and you can able to check it. Yeah, this is the functionality. Got the point. The same thing. Suppose question is that what? Tell me now. I drop this original table. There will be impact. Huh?
No.
No
No.
impact. No, both are independent. No. So you should
Yes.
say straight away. So they won't have any impact. Now what happened? Now this table will be dropped. See now what happened? Now see this table will be dropped. Now this will be available. That's what the function. Simple. So see, got a point. So there. So because now both are point same thing. It won't have any impact when you try to perform the same. Okay. So far. So your task is that what? Okay, so this is important. So what happened? Create table with the following columns. Name, syntax, like constants, insert 5 records, do backup table. See it as like syntaxes is important. After 2 hours, check in information schema dot storage metrics, ID, clone group ID, active byte. Tell me why you should wait for 2 hours?
Latency.
Latency of 2 hours is there. Okay, if you want to get reflected, we can able to get it done. So where exactly active bytes will be populated?
Storage.
Only for CTAS and main table.
Yes.
Okay. So like and clone, no thing. Okay. Tell me how to find table is normal or cloned table.
ID and
Clone
Clone
group
group
ID.
ID.
Group ID.
clone group ID are same.
Does
So the
cloning uses
different
virtual?
is
Tell me,
different and
does cloning uses virtual warehouse?
No,
no,
No. Does cloning uses Occupies storage?
no.
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 Okay, so
No.
theory is fine, but we need to confirm and we can say. So can we clone the clone table again?
Yes.
Mm,
Yes.
yeah, we can. Yes.
Now see, we have cloned this clone table. Now question is that what? So can we clone the cloned table again?
Yes.
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 This is possible. So again, can you clone the clone table?
Yes.
Yeah,
Yes.
we can.
Okay. Now question is that one. Now this table is pointing to which one?
The
Base level.
Main table.
This one or base table?
main
Tell me, don't get confused. So it should be okay. Tell me. So all things will be point to the main table itself.
table.
Main table.
Okay. How to confirm? How to confirm?
ID is
ID by checking the IDs.
yeah. Clone group ID is matched with the original table ID.
Now see, 614448 for all things. Nothing but what? See, all these tables are pointing to main table
Main.
itself. Now tell me now, after 2 words, where exactly data will be populated? Only this data. Okay, so this will be 0, 0. Okay, and that's the way you can able to get it done. Okay, clear? So this is the way you can able to make it, but okay.
But sir, as the clone table is pointing to the same storage, if we do delete operation in the clone table, so will it get is the base table get impacted or how it is?
No, both are independent.
No, no. What your question? See, you perform in delete.
Yes.
No, delete will be delete. So now what happened? This partition will be removed.
No, I think he asked deleting clone table.
No, vice versa. Tell me which you're asking for what?
Yeah, if I delete a record from clone table and if that is pointing to the same storage, then
No, here no,
is the
this
base
will be
table get
this will be
affected?
removed. No, that's one now. Tell me you should say listening one now. Tell me it will reflect or not. Anybody tell me?
So it
Question
will
is
not
that
impact original table.
no, nothing. No. So up to this point of time, so both are having the same storage and same records. If you try to insert delete, nothing will get to this guy. If you try to insert delete, because no, both are independent. No, so that's fine.
Yeah.
Will not affect.
No, nothing will
Nothing
get.
affect. Yeah, nothing
Nothing
will.
will get affected. Okay, this was the function. Okay. Now one tricky question.
So
Tell
if
me
you
how to find it. Who dropped the table? Any guess?
user, is there any username set?
Something like tell me if I execute anything where you can find the
Drop
query
table.
is drop table. So T6
Table.
CL9. Okay. Now what happened for everything? There is a
Query
what
is
is this?
profile.
Query profile. Okay, query profile. So 3. Okay. We can go to query profile.
There is.
3 dots where? Okay. We can get here. Go to the same thing. 3 dots. I can go for the same thing. So go to where? Query history.
History.
Okay, so filters, SQL text,
Yeah,
search
user.
for
We can say users.
drop. So these are the users only. Okay, see drop. Okay. So now what happened? Click the same thing. Now drop by whom? See, this is the username. So drop by whom?
User.
User is there.
So apply filters. So Praveen is there. Okay, so you can able to. Okay, directly can't we should go for the query and we need to figure out the function. Got the point? So you should do the task. Okay, then only you can able to be comfortable.